Welcome to the Groundwater Restoration and Introduction to Environmental Engineering online webinar. My name is Amy Kessner, and I am the Program Manager for the Groundwater Restoration Program. Today I will be walking you through the program so that you may easily incorporate it into your classroom or extracurricular activity. Groundwater Restoration is a Groundwater Foundation program and is sponsored by the Captain Planet Foundation and the Nebraska Environmental Trust. The Groundwater Foundation is a nonprofit organization whose mission is to educate people and inspire action to ensure sustainable, clean groundwater for future generations. The Groundwater Restoration Program was designed to educate youth on the importance of our groundwater, threats to our groundwater resources, and the challenges of cleaning up polluted water, with the hopes that our youth will become stewards of this precious resource long into the future. Resources to assist you with the implementation of groundwater restoration can be found on the Groundwater Foundation's website at www.groundwater.org/kids/getinvolved/restoration.html. Resources include this webinar, a 3-part lesson plan designed for teachers, a corresponding student worksheet, and a link to the awesome Aquifer kit we use in our program. Groundwater restoration is divided into a 3-part activity. In Part 1, students learn that groundwater is the water that is stored in and moves slowly through layers of soil, sand, and rocks called aquifers. Since visualizing groundwater can be difficult for some students, using a model aquifer is an effective way to help students understand important groundwater concepts. The materials needed for Part 1 of groundwater restoration are the Part 1 student worksheet, a cup, and an awesome aquifer kit. If you do not have an awesome aquifer kit, you can use a clear container, such as a 2-liter bottle cut in half that has been filled with aquarium gravel instead. You may also wish to use a towel if you are doing the activity indoors, as any activity involving water can be very messy. Once you have gathered all of your materials, you are ready to begin Part 1. The first step to Part 1 is dividing your students into groups of 4 to 5 students. An optional but fun activity is to assign the students different roles to play throughout the activity. You can come up with the roles yourself or use our pre-made roles of team leader, supply chain analyst, procedure manager, data manager, and lead engineer. These role cards can be found in the Part 1 of the Teacher's Guide. Once the students have been split into groups, the fun begins. First, explain to your students that today they will be making a model aquifer. Many of your students may not know what an aquifer is, so explain to them that an aquifer is a layer of soil, sand, and rocks that stores water known as groundwater below ground. The layer of gravel in the aquarium represents an aquifer, making it a model aquifer. However, their aquifer is currently empty and needs to be recharged or refilled with groundwater. So have the students take the cup of water and slowly add water to their model aquifer while watching the water level increase. Tell your students to stop adding water when about half of the gravel is saturated or full of water. You can now explain to them that the saturated or full part of the aquifer is now filled with groundwater. This groundwater is stored in and moves slowly through the cracks and spaces of the aquifer. Groundwater is an important natural resource we use every day for drinking, recreation, industry, and agriculture. After explaining the concept of groundwater to your students, have them create a lake in their model aquifer. To do this, the students should push the gravel to one side, or both sides, of the container, allowing the water to pool and create a lake as shown in the picture. This lake represents surface water and will allow the students to see the surface groundwater connection. You can explain to your students that surface water is water above the surface of the land, including lakes, rivers, streams, ponds, floodwater, and runoff. Once the students have created the lake, have them find the water table. The water table is the top of the saturated zone in their aquifer. It should be the same height as the lake as shown in the picture. The students can use the image on the student worksheet to help them identify different parts of their model aquifer, including the water table. Once they have found the water table, have them pretend it is raining and add more water directly to the aquifer from their cup. Ask them what they have observed. Did the water table increase or did it decrease? The water table will have increased as the rain was recharging or refilling the aquifer. Furthermore, the height of the lake should have increased as well, since there is a direct connection between the groundwater and the lake. This is part of the water cycle. Some other questions you may wish to ask can be found in the teacher's guide. Part 2 of Groundwater Restoration is designed to introduce youth to the concept that our actions and choices matter when it comes to groundwater. Choosing to use less water in our day-to-day lives can help keep groundwater sustainable for future generations. In Part 2 of Groundwater Restoration, students will learn about human impact and common sources of pollution to groundwater. At the Groundwater Foundation, we believe that understanding how our choices can lead to polluted groundwater can help us make better decisions to protect groundwater in the future. The materials needed for Part 2 include the model aquifer from Part 1, the Part 2 student worksheet, potting soil, vegetable oil, vinegar, salt, baking soda, and food coloring. We also highly recommend some form of reusable storage containers or cups. And for extra fun, you could also include a small toy boat or origami boat for this part of the activity. In Part 2 of Groundwater Restoration, common household goods are used to represent 6 common pollutants to water. Colored water represents household chemicals, potting soil represents sediment, vegetable oil represents petroleum or oil, salt represents road salt, baking soda represents pesticides and fertilizers, and vinegar represents acid rain. You will want to distribute the 6 pollutants to each group of students, allowing each student to have 1 or 2 pollutants. We highly recommend pre-sorting the pollutants into small storage containers or cups to reduce mess and control the amount of pollutant the students add into the model aquifer. Recommended amounts of pollutants can be found in the teacher's guide. Once you have distributed the pollutants, you may begin having the students introduce the pollutants to their model aquifers one by one. First, have one student pour the colored water over one spot on the gravel. Explain to them that this colored water represents all household chemicals, such as cleaners. Household chemicals can permeate or spread throughout the soil and seep into groundwater if not properly disposed. Students may notice that even though they poured the colored water over the gravel, their lake is starting to change color as well. Once again, this is showing the groundwater-surface water connection and the water cycle as the water moves slowly from the groundwater to the surface water in a process known as discharge. Second, have the assigned student from each group add the potting soil to the lake. Explain how when natural vegetation is removed, such as during deforestation or construction, sediment or soil can wash into surface water. Too much sediment can hurt aquatic life by making it difficult to breathe and by blocking much needed sunlight to aquatic plants. Third, have the assigned student from each group add the vegetable oil to the lake. Explain how oil spills can occur when oil is being transported. They are very difficult to clean up and the oil can seep into the groundwater. Furthermore, even small oil spills from vehicles can pollute water. For extra fun, add the oil to a toy boat or an origami boat and have the students spill the oil from the boat, simulating an oil spill. A photo of an origami boat made from used sticker sheets is shown in the top right corner. This is also an excellent opportunity to discuss upcycling or reusing materials for a new purpose instead of just throwing them away. Fourth, have the assigned student from each group add the salt along the edge of the gravel and lake. Explain how salt is used to keep ice off the roads during the winter and keep us safe, but that too much salt is bad for the environment. Salt can kill plants and pollute our waters. Do you like drinking salt water? Fifth, have the assigned student from each group add the baking soda all over the gravel in the model aquifer. Explain how this baking soda represents pesticides and fertilizers. Pesticides are chemicals used to kill insects that can destroy our crops, and fertilizers are nutrients that help plants to grow. Both are good things when used in proper amounts. However, too many pesticides and fertilizers added to our gardens and croplands can be harmful to our environment and can pollute our groundwater. Finally, have the assigned student pour the vinegar all over the gravel and lake as if it was raining. Explain that the vinegar represents acid rain. When air pollution reacts with water in the atmosphere, acid rain can develop. Acid rain is very damaging not only to the environment, but to building structures as well. The reaction between the baking soda and vinegar is also fun for the students and helps demonstrate the corrosive power of acid rain. You can see it bubbling up in the photo. You might even decide to use this portion of the activity as an added chemistry lesson. The vinegar is the final pollutant to be added to the model aquifer. Once this is done, you are ready to move on to part 3 of groundwater restoration. Now that your students have learned the basics about groundwater and how it becomes polluted, it is up to them to design and create a device to clean up the groundwater in their model aquifer. After all, they can't leave the water polluted. This task will not be easy, but you can explain to them that with a little teamwork they will soon be on their way to remediating or cleaning up the groundwater and bringing about groundwater restoration. The materials needed for this portion of the activity are the polluted model aquifer from Part 2, the Part 3 student worksheet, sponges, a syringe, a clear plastic cup, dome lid, coffee filters, nylons, rubber bands, cotton balls, string, tape, scissors, straws, an ice cube or paint tray, paper towels, pre-rinsed activated carbon, and rinsed sand. You do not have to use all of these items, and you could choose to add in a few items of your own not listed here. We recommend using an assortment of items that include some that can effectively filter water and some items that do not effectively filter water. Before students begin designing their water filter to clean up their polluted aquifer, they first need to test their available materials to see how they can be used to clean the water. The student worksheet has a chart where they can record the results of their experiments. To experiment, we recommend using an ice cube tray or a paint tray and placing a small amount of a given material in one space, and then using the syringe to test a small amount of the polluted water. Of course, before beginning the experiment, it is important to note the state of the polluted water prior to any filtering. Have the students write down their observations. What color is it? What types of particles are visible? What does it smell like? Then, they can record their post-filtering observations in the chart. For example, the coffee filter removed dirt particles from the water, and as the student noted in the photo, the carbon cleared out coloring or removed the food coloring from the water. Once the students have tested the different materials available to them to create a filter, they can begin the design process. The student worksheet has a place where they can draw their design. This design should be labeled and approved by a teacher before beginning the actual building of their water filter. As shown in the photo on the right, the Groundwater Foundation recommends 2 methods for filtering water, one with the dome lid upright and one with the dome lid upside down inside the cup. Both methods can be very effective. Feel free to give students this hint when they are beginning their design process. An example student design is shown on the left. In this example design, the students chose to place the dome lid upside down inside the cup, and they used the coffee filter to block the dome lid hole and filled it with activated carbon and cotton balls. They also used a sponge held over the cup to add an additional filter to their design. Once their design has been approved, the students can start building their water filters. Some students may realize when they first test their filter that it doesn't work as well as they had hoped. Encourage them to keep working together to diagnose the problem and come up with a new solution. One common problem is the filter works too slow. Items like sponges and cotton balls can be very absorbent and either require large amounts of water or squeezing in order to speed up the filtering process. Once the students have completed their filter, they can visit with other groups to see what worked and didn't work for their filters. This is an excellent opportunity to have students practice public speaking by presenting their design to the class and explaining the logic behind their design and what worked and what didn't work. Once the students are done presenting, you may wish to review the importance of groundwater and keeping it clean. Emphasize that it is much more difficult to clean polluted water than it is to prevent pollution in the first place. After your final talk, you have officially completed the groundwater restoration activity. Groundwater restoration was piloted in 5 elementary schools, and feedback was taken from the students. The results show that 96% of students thought groundwater restoration was fun, 86% of students learned something new about groundwater from groundwater restoration, and 97% of students thought groundwater conservation and protection was important after participating in the groundwater restoration activity. Thank you for listening to the Groundwater Restoration webinar. For more information on groundwater restoration, please contact the Groundwater Foundation at info@groundwater.org or by calling 402-434-2740.